All right, today we're going to talk about calculus, but probably not like you're used to. Forget the scary reputation. We're going to approach this like we're building a practical, powerful toolkit, one that's going to help you solve problems with a lot more confidence. So let's get into it.
First things first, let's just reframe this whole thing. What if calculus isn't some big scary test of how smart you are? What if it's more like woodworking or being a mechanic? It's not about genius, it's about knowing which tool to grab for the job at hand. When you think about it that way, everything kind of changes.
So, that's exactly what we're going to do. We're going to build your toolkit, piece by piece, starting with the absolute must-haves. By the time we're done here, you'll have a set of go-to tools that you can rely on.
Okay, tool number one. This is a big one. It's the cornerstone of calculus, the derivative. The best way to think about it? It's your rate of change detector. Its whole job is to tell you exactly how fast something is changing at any single instant. You know, like figuring out a car's speed right now, just from its position. It's a super powerful concept.
Now, when you open up that derivative drawer in your toolkit, the first thing you're going to grab, probably 90% of the time, is the power rule. Seriously, this thing is like the multi-tool of calculus. It's versatile, it's essential, and you are going to use it constantly.
So what does this awesome multi-tool actually look like? Well, here's the formula. And the beautiful thing about it is how simple it is. If you have a function like x to the power of n, its derivative is just n times x to the power of n minus 1. That's it. Let's actually see it in action.
Let's try it with 3x to the fourth power. Step 1, you just multiply the number out front, the coefficient, by the exponent. So 3 times 4, that gives us 12. Easy enough. Step 2, just subtract 1 from the exponent. 4 minus 1 is 3. And for the final step, you just stick them together. And there's your answer, 12x cubed. See? Not so bad, right?
And if you're worried you might forget those steps, here's the only phrase you need to remember. Just burn this into your brain, bring the exponent down, subtract 1. That is the power rule in a nutshell.
Okay, next up in the toolkit is a more specialized piece of equipment. This is the product rule. You pull this tool out for a very specific job, when you need to find the derivative of two functions that are being multiplied together.
Now, here's the formula for it, and I know, at first glance, it might look a little complicated, but it's really just a simple, balanced pattern. All you do is take the derivative of the first part and multiply it by the second part untouched. Then you add the first part, untouched, multiplied by the derivative of the second part. It's got a really nice rhythm to it once you get the hang of it.
All right, time for another specialty tool. This one is a real secret weapon, the chain rule. This is the tool you need when you're dealing with a function that's nested inside of another function. Think of it like those Russian nesting dolls, one inside the other. And again, the formula might look a little weird, but the process is super logical. You always start from the outside and work your way in. So, you take the derivative of the biggest, outermost doll, but you leave the inner doll completely alone. Then you multiply that whole thing by the derivative of the inner doll. But, how do you keep that straight in the heat of the moment?
Well, you use this little phrase. It cuts right through all the noise. Outer first, inner second. That simple trick right there makes the chain rule so much easier to handle. It's all about remembering the order of operations.
So, we've got the first tray of our toolkit pretty well stocked. Time to move on to the second tray, and this is where we meet the integral. Now, if the derivative was our rate of change detector, then the integral is our area finder. Its job is to calculate a total accumulation, like the total area under a curve or the total distance a car has traveled over time.
And here is the absolute most important thing you need to understand about integrals. Integration is simply the inverse of differentiation. That's it. Just think of it like the undo button for a derivative. It takes you right back where you started.
So here's the basic formula, and if you look closely, you'll see it's literally the power rule but backwards. Instead of subtracting 1 from the exponent, you add 1. Instead of multiplying by the exponent, you divide by the new one. Oh, and see that little plus c at the end? That's the constant of integration. Don't forget him. He's a really crucial little detail. Now, it's super important to know that there are two kinds of integrals. You've got your indefinite integral, which gives you a general formula as the answer. But then you have the definite integral, which has those little numbers on the top and bottom. That one gives you a specific number as an answer. It's kind of like the difference between having a general blueprint versus having a final exact measurement.
You know, every good toolkit needs a few of those weird little gadgets that just save you a ton of time and effort, right? Well, when you're dealing with trigonometry and calculus, one of the most useful little time savers is the Pythagorean identity.
This rule right here, sine squared x plus cosine squared x equals 1, it is so foundational. What it means is, if you know the value of sine, you can always find cosine and the other way around. So let's say you're in the middle of a huge, complicated problem and you figure out that sine of x is 1/2. This identity lets you find cosine immediately without having to do a bunch of extra work. It's a fantastic shortcut.
So, we've filled our toolkit, we've got derivatives, integrals, a slick trig shortcut, but you know, the tools are only as good as the person using them. You need a strategy. So here it is, your master plan for putting all these tools to work.
This is your 4-step game plan for pretty much any problem they can throw at you. First, just stop and identify the right tool. Is this a product rule problem, a chain rule problem? Second, physically write down the formula you're going to use. It really helps focus your brain. Third, just calculate carefully, follow the steps. And finally, clean it up, simplify your result. This simple strategy turns what looks like a big, scary problem into a totally manageable checklist.
And there you have it. Your starter toolkit for calculus is officially built, it's organized, it's practical, and it's ready to go. You know, calculus is really the language that describes change in the universe. And now you have the tools to understand and speak that language. So the only real question left is, what problem are you going to solve first?